You know, we've all seen drones go from being these cool little toys to incredibly powerful tools. But the next big leap forward, it's not about fancier cameras or batteries that last longer. Nope, it's about something way more profound: intelligence. We are literally moving from a world where it's one person flying one drone to a future where entire teams of drones can think, learn, and work together all on their own. So let's dive into how this all works.
And make no mistake, this isn't some far-off future stuff. Drones are already making a huge impact. For search and rescue teams, they're the eyes in the sky that can go where people can't. They're making package delivery way faster. They're building these unbelievably detailed 3D maps for everything from city planning to farming. And yeah, for both military and environmental monitoring, they give us critical information without putting human lives on the line. The bottom line is, they're everywhere, and they're becoming absolutely essential.
Okay, so that's all great, right? But it leads us to a massive problem. As incredible as these drones are, their effectiveness often hinges on this one single component that just can't scale: a human pilot.
And what's really interesting is how we've done things up until now. On one side, you've got full manual control. A pilot with a joystick who needs to keep the drone in sight and hope the radio signal stays strong. Then you've got these semi-automatic systems where you can program a route with GPS coordinates and the drone just follows along. And sure, that's helpful, but they're not thinking. That's the key difference.
So here's the crucial point. These old methods are incredibly brittle. Radio signals get jammed, you need highly trained pilots, which creates a huge bottleneck, especially when you need to act fast. But most importantly, a drone that's just following a pre-programmed path can't react to, say, a bird flying in front of it or a sudden gust of wind. It's just following a script, right? And in the real world, things never go according to script. That's a huge, huge problem.
So how do we get past this bottleneck? Well, this is where things get really cool. We have to teach the drones to think for themselves, and that's where the magic of machine learning, and specifically a technique called reinforcement learning, enters the picture.
Okay, so what is reinforcement learning, or RL? You can think of it as learning by doing, basically. Instead of just dumping a ton of data into a machine and telling it to memorize patterns, you give it a goal, you put it in a virtual playground, and you just let it figure things out through trial and error.
Honestly, the best analogy you'll hear for this is training a puppy. It's perfect. When the drone does something you want it to do, like it gets closer to its landing spot, you give it a digital treat, a reward. When it does something bad, like bumping into a wall, it gets a penalty. Over thousands, even millions of these attempts, it starts to build an intuition for which actions get it the most treats.
And this diagram right here, it just lays it out perfectly. It's this simple, but incredibly powerful loop. You've got your agent, that's our drone. It takes an action in its environment. Then, the environment sends back two critical pieces of information. What's the new situation, and was that action good or bad? The drone uses that feedback to decide its very next move, and it just keeps getting smarter and smarter.
So you might be asking, does this actually work? Oh yeah, it works incredibly well. In one study, they used this exact method to train drones for really complex navigation, and they achieved a staggering 92% success rate. I mean, think about that. That's not just a small improvement. These drones weren't just following a map anymore. They were actually learning to navigate on the fly.
Okay, so a single smart drone? That's amazing. But that's just the first step. The real revolution, the next frontier, is when we get them to learn and work together. That's when we go from a solo act to a fully coordinated swarm.
So take a look at this. On the left, that's our simple loop we just talked about, right? One drone, one environment. Simple enough. But now look to the right. Whoa, it gets way more complicated and way more interesting. Each drone isn't just dealing with the environment anymore. It's also reacting to what every other drone is doing at the exact same time. The whole thing becomes this living, breathing network.
This is what's known as multi-agent reinforcement learning, or MARL, and its single biggest challenge is a concept with a fancy name: non-stationarity. But all it really means is that the goalposts are always moving. The rules of the game are constantly changing for every drone because all the other drones are also learning and changing their strategies at the same time.
And, this analogy is just perfect for it. It's the difference between a classical orchestra with a conductor and a jazz ensemble. This is how you solve that moving goalpost problem. In jazz, each musician is improvising, doing their own thing, but they're also constantly listening to everyone else and adapting on the fly. The result is this incredibly complex, beautiful music that emerges without a central leader telling everyone exactly what to play.
Right. So how do you teach a whole group to improvise together like that? You need a coaching strategy, a playbook. And in the world of AI, that means picking the right algorithm to encourage that kind of teamwork. Let's take a look at the playbook.
So you can basically break it down into two big ideas. One is called value-based. Think of a chess supercomputer calculating the exact point value of every possible move it could make. It's very calculating. The other way is policy-based. This is more like a star athlete developing reflexes and instinct. They're not calculating the physics of a ball, they've just developed an intuitive strategy for how to react in any situation.
And you don't just pick one at random. You've got to pick the right tool for the job. So as you can see here, if you've got a predictable space, like a warehouse, where all the drones have to work together perfectly, a value-based approach is your go-to. But if you're out in the real messy world with unpredictable things happening, a policy-based approach is going to be your best bet. And then you have this other thing, federated learning, which is super cool for when you have massive swarms that need to learn from each other without sharing all their private data.
Okay, so for what we're talking about, these big drone swarms, those policy-based methods are usually the star of the show. There's one algorithm in particular called MAPO, and it's become a real favorite. Why? It's all about that athletic instinct we mentioned. It just creates really stable, reliable behaviors that don't totally fall apart when you scale up to dozens or even hundreds of drones. And that right there is crucial for making this stuff work in the real world. Okay, let's take a step back for a second. We've gone from a single drone to learning swarms, and we've even looked at the AI playbook. But what about the so what? Why does any of this really matter?
Well, unlocking this kind of swarm intelligence, it's not just an upgrade, it's a complete game changer. Just imagine a search and rescue mission where an entire swarm of drones can map out a huge area in just minutes. Or think about a fleet of drones instantly creating a communications network over a disaster area when the cell towers are down. We're talking about defensive systems that can adapt to threats on their own, or huge fleets of drones that can make logistics and agriculture incredibly efficient. This is what makes all of that possible.
And that really brings us to the final thought here. The technology isn't just coming, it's here, and it's getting better at an incredible speed. As these intelligent swarms become a reality, with the power to learn and solve problems as a team, the possibilities are just mind-boggling. So I want to leave you with this question. If you had a swarm of intelligent, adaptive drones at your command, what's the very first problem you'd want them to solve? Because the answer to that question, that's probably going to shape a big part of our future.